So let's talk about parent functions. We teach Algebra 2 from a functions-based approach. That means we talk about the functions, we talk about the transformations of those functions, and a lot of the stuff we do is based on the actual functions. Well, that's great and fine and good and all as long as you know what the functions are. Okay? Some of these functions in this worksheet you really focus on in Algebra 1. Some of them you've never seen before, but we need to cover them in Algebra 2. So for the first couple days of school, we're just going to basically talk about a lot of the functions we're going to deal with this year. Some of these other functions toward the back, we're not going to get to in the first couple days of school because we're not going to talk about them till mid-second semester. So I don't want to talk about them yet. I want it to be like something you look forward to, like some foreshadowing. Okay? So let's start here. F of x equals x. What's f of x the same as, by the way? Do you remember? Y. F of x is the same as y, right? This is just listed in function notation. Y would just be an equation, right? Y equals x is just an equation. This is telling you specifically this is in function notation. So what kind of shape does this make when you graph it? Do you know? Y equals x? It's a line, right? If it makes a line, what kind of function is it? It's a linear function. Okay? So let's go down over here to the table, right down here, and somebody tell me an x value. 1. So if x is 1, I go over here to my equation and I say y equals x. If x is 1, what is y? Yeah, because if y equals x, aren't they the same? Okay, somebody else give me another x value. 3. If x is 3, what is y? 3. Another x value. Somebody else. 8. If x is 8, what's y? 8. What else? 9. Can we say negative 9? Oh, negative 9. Okay, excellent. Negative 9. If x is negative 9, what's y? Because they are the same, correct? Give me one more value. 64. If x is 64, what is y? 64. Okay? Thank you for saying that because that gives us a conversation starter for just a second. Good job. Okay? Let's go ahead and graph these points up here on our graph. If x is 1, oh, I got to get my glasses on. If x is 1, y is 1. If x is 3, y is 3. If x is 8, y is 8. And if x is negative 9, y is negative 9. If x is 64, is this one right? It is, right? But it just doesn't fit on my graph, right? So while this is a true statement based on my table, based on my equation, I can't graph it, can I? So sometimes, especially when we're trying to see the parent function, the original function, we want to choose values that we can see on our table. It's not wrong, for sure, right? But we want to maybe choose values that we can actually see on a table. Is that fair? Okay. Now, am I allowed to connect these dots? How do you know that? So just because it looks like it makes a line, we can willy-nilly draw a line? It will, right? Because that would be something that fits on my table. I could put a 0 here and a 0 here, so I would know it goes through the origin. But there's actually a reason that I know that I can connect the line, the points. And the reason is we got it from this equation, which I was told from the beginning is a function, right? And we know that because it's in function notation, it's f of x. And that's the only reason I know I can connect the points, not just because they look like they make a line, right? But see what's cool about that is that once I know that I can connect them, I also know this function is continuous. There's no breaks in this function. There's no holes in the function. It's a continuous line. Now, some people get confused and think that it's continuous because it keeps going, right? There's arrows on the end, so you know it keeps going. But guys, that's a function that is continuing. Continuous has a specific definition. Does that make sense? Okay. I'll go ahead and tell you right now, we're going to skip this box in all of the the problems that we do today. We're going to talk about it, just not yet. Okay. So let's go up here and talk about domain and range. Have you ever heard of domain and range before? Okay, good. That makes me happy. Okay. What do you know about domain and what do you know about range? You just remember hearing the words, or you know something about them? Domain is X, right? The domain is the X's. The X's. And the range is what? The Y's. So domain, the X's, we're talking about left to right. Would you agree with that? If we're talking about the X's, that's left to right. So what about range then? Okay, can we argue for a second about that? Is that okay? Okay, so if domain, we're talking about left to right, what are we talking about? Negative to positive, right? So for domain, we talk about negative to positive. Should we also talk about it that way for range? So what way should we talk about for range? Down to up, right? I know you said up and down, and I wasn't disagreeing with you. I just wanted to argue with a little bit to make sure you understood why we always want to talk about down to up. Because we always want to talk about least to greatest. Does that make sense? Okay. So in this particular problem, if we're talking about left to right, how far to the left does this graph go? Forever. And how far to the right does it go? So there's two ways we want to be able to write that. We want to be able to write it in inequality notation, and we want to be able to write it in interval notation. In Algebra 1, mostly all you ever talked about was inequality notation. In Algebra 2, we've got to be able to do both, because most of the time in college algebra classes, they only talk about interval notation. So it's one of those things where you learned it one way, and that's a good way to learn it, but we've got to be able to learn it two ways so that when you get to college algebra, because see, like I know how I teach it in college algebra, I know how Cisco and Hearn Simmons teach it for college algebra, but I don't know about Tech, I don't know about UNT, I don't know about WT, I don't know about Notre Dame, I don't know about that stuff. So I want you prepared to use either one. Is that fair? Okay, so probably what you're used to writing is like all real numbers, right? For domain, or using the symbol all real numbers. Do you remember that? No? Okay, so what are you used to talking about when you talk about domain? Do you remember? That's fair. You don't. If you don't remember, that's okay. That's my job to help you remember, right? Okay, so sometimes you wrote all real numbers. Sometimes you wrote the symbol for all real numbers. I don't mind if you use the symbol for all real numbers because it's quicker. Okay, as long as you remember what that symbol means. Is that fair? Interval notation, though, looks like this. What do you suppose that means? Doesn't that mean all real numbers? All the way to the left, negative infinity, right? And all the way to the right, all the way to positive infinity. Does that make sense that it means the same thing as all real numbers? Yeah? Now, just to be clear, this is going to sound a little strange because of what I just wrote, but there's no such thing as negative infinity. It's just infinity, right? To the left, infinity to the right. What we do, though, in math is we give ourselves a clue, like a hint. We're talking about to the left, so we say negative infinity. Because there's going to be times that it doesn't go all the way to the right. So we need to make sure we're talking about all the way to the left and all the way to the right. Does that make sense? Okay. What about range? How far down does it go? All the way. How far up does it go? All the way. So for range, I also have all real numbers and negative infinity to positive infinity. Can we jump down back over here by the table for a second and talk about x-intercept and y-intercept? Are you okay with that? Where does this function cross the x-axis? Remember, this is the x-axis right here. What point is it crossing the x-axis? 0, 0. Good job with that, because some people earlier, they were saying, oh, 0. Well, 0 is a number. It's not a point, is it? Okay, so we make sure we name the point. Where on the y-axis is this crossing? Oh, same place. Is that okay? That the x-intercept and the y-intercept are the same? Yeah, for sure. That's fine. All right, maximum and minimum. What do you suppose maximum means? The highest point, right? The highest that it gets. So where's the highest point that this line gets to? It's infinity, right? Do you know where the end of infinity is? Me neither. So is there a maximum point on this graph? No, there's not. I just write none, because there's not one. But what about minimum? Oh, that's also none, isn't it? Because there's not a lowest point that it gets to. Intervals of increase and decrease. I need you to remember that this deals with domain. So that this is dealing with x values. Only domain. Okay? So when we're talking about the intervals, we're talking about left and right then. Okay? So when we're talking about these intervals, I start on the left and I say, as I'm moving to the right, where is this graph increasing? Can you tell that it's increasing the whole time? Because I'm starting on the left and I'm just following the path of the graph. Where is it increasing? The whole time, right? So it's increasing over the whole domain. And maybe that's a little confusing at first until we start to talk about the intervals of decrease. As I'm going from left to right, where is this graph decreasing? It's not, is it? What do we write, you think? None. There's not any intervals of decrease. Now, end behavior, I think I need to translate a little bit. Can I do that for you? As x is going to the left, think about on the far, far, far end of this graph. As x is going to the left, what's happening to the y's? It's going down, right? So as x is going to the left, the y's are going down. So they're going toward negative infinity. Does that make sense? Okay. As x is going to the right, what's happening to the y's? As x is going to the right, the y's are increasing. So what do you think I'm going to put? Infinity. Yeah. Any questions? So that's the first one. That's an example of what we're going to do. Okay? Look at the next one. Do you know what that's called? Any guesses? Absolutely, it sure is. Absolute value. Is it all right if we start at the table first again? Okay, so give me some values. Thinking about what we talked about things that we want to be able to fit on the table, on the graph if we can, right? What'd you say? 1. So if x is, what does this mean though? What does absolute value mean? Some people earlier said it's always positive. So that's a good way to think about it, but that's not exactly what it means. So that's a good guess, but not quite. That's exactly what it is. It's a distance. A distance from what? 0. From 0. Okay? Can I have a distance that's negative? No. We'll fight about that later, but for right now we're going to say no. Okay? We can't have negative distance. So that's why the number that comes out of the absolute value seems like it's always positive, because it's a distance that we're talking about. Okay? So if we say x is 1, what's y? What's the positive distance from 0 of 1? Yeah, 1. What about negative 1 then? How far is negative 1 away from 1? Excuse me, I have to say that better. How far is negative 1 away from 0? 1, right? What if it's a positive 2? How far is 2 away from 0? 2. So what about negative 2? How far is negative 2 away from 0? Okay, positive 2, right? Does everybody understand that? Okay, give me one more value. Negative 10. How far is negative 10 away from 0? 10. Okay? So let's plot these on the graph. 1, 1, negative 1, 1, 2, 2, negative 2, 2, and negative 10, 10. This doesn't look like a line. And you're going to say, well, that's okay because it's not. Right? What if we added one more? I know there's not space for it, but we can make space for it. What if I added 0? How far away from 0 is 0? Okay. So that gives us one more point. Does that help? Guys, what does absolute value look like? A V. Can I connect them? How do you know? Because it came from an equation, right? Okay. Came from a function. See, it looks like a V. What's the x-intercept? 0, 0. What's the y-intercept? Oh, yeah. Once again, it's the same place, right? Is it always going to be that way? No. So what did we decide about this function then a minute ago? It is continuous, and why is it continuous? Because I could connect the dots, right? Okay. Where is its maximum value? So if it goes to infinity, it doesn't have a maximum value, does it? Okay. Where is its minimum value? Oh, it is. You're right. Right? Doesn't it stop? It doesn't go all the way to negative infinity, does it? It stops at 0. So the point where its minimum value is 0, 0. So while we're at it, let's talk about the domain and the range. We were just talking about the range, weren't we? Because we said, while it goes all the way up, it doesn't go all the way down, does it? It stops at 0. So it goes all the way up, but it doesn't go all the way down. So where does it start? Like how far down does it go? 0, and how far up does it go? So it starts at 0. So y is everything greater than or equal to 0. That's our inequality notation. Okay? Our interval notation looks like this. Now please notice on the 0, there's not a parenthesis this time. There's a bracket. That's because 0 is included as part of our range. And there will be a time here in just a minute where that won't be a bracket, but I hope you'll understand why when we get there. Is that fair? Okay. So what's the domain? How far to the left does it go? All the way? And how far to the right? All the way. So we write all real numbers or negative infinity to positive infinity, right? Yes, sir.
So the two for range, how you wrote the
Two different ones, yes, sir.
Are those just interchangeable?
They are. And it depends on what the directions ask for. If it asks for inequality notation, this is the answer. If it asks for interval notation, this is the answer. But for the record, that's something we're going to focus on next Tuesday. So for now, just kind of go with me and we'll focus when we get there. Is that fair? Okay. Where is it increasing? As I'm going from left to right, is this increasing? Yes. So on the right-hand side of 0 is where it's increasing, right? So I would say starting at 0 and going to positive infinity is where it's increasing, right? Here's that place I was telling you about. Why don't I have a bracket around 0? Well, why don't I have a bracket around infinity? Okay, we're not going to ever put a bracket around infinity because putting a bracket around it implies that it includes the end of infinity. Do you know where the end of infinity is? Yeah, me neither. We can't do that. We have a bracket around this 0 right here because it includes 0. This doesn't include 0 because we're talking about an interval of increase. Can something be increasing at a point? A point is just a point, isn't it? It doesn't increase until after that point. So we don't include the point where it changes direction. Either way, we don't include the point where it changes direction. Okay? So, where is it decreasing? As I'm going from left to right, is it decreasing? Yes. So it's decreasing on the left-hand side of 0. Now, I don't want you to be confused by this. Some people get confused by this because they're like, look, it's increasing. Except what was I really clear on when we started? As we go from left to right, right? We're not going this direction. We're going this direction. Does that make sense? Okay. So where is it decreasing then? So it stops decreasing at 0, 0. I agree with that. But it's decreasing on the left-hand side of that, right? So is it decreasing from 0 to a negative infinity? No, because we always go least to greatest, right? So it's decreasing from negative infinity to 0. Yes? Okay. End behavior. As x's are going to the left, as the x's are going to the left, what's happening to the y's? They are increasing, aren't they? So we say it's going to positive infinity. That's not what we wrote up here on this one. Because as x's were going to the left here, what was happening to the y's? They were decreasing, weren't they? Do you see the difference here? As x is going to the left, do you see that the y's are increasing here? Okay, so what's happening as x is going to the right? It is also increasing. Is that allowed for it to be the same? Yeah, especially if that's what's happening in the graph, right? Sorry, I don't know the bell times yet. And they're different from last year. 31. So we have 10 minutes. We're good. Okay, ready? Any questions on linear or absolute value? Good? So what do you think my first question is going to be? Yeah, what's it called? There's the equation. It is x squared. I agree with that. But it has a special name. Do you want a hint? Okay, starts with a Q. Close. First 4 letters are right. Ooh, first 5 letters are right. Uh-huh. That's correct. It's a quadratic. It is x squared. And some people earlier even said parabola, which is also good, but a parabola is the shape a quadratic makes. Does that make sense? Okay. So, let's go to the table. Remembering that we want things that will actually fit on the table if possible, what kind of x's are you going to choose? Which one's usually safe? 1. 1, for the record, 1 and 0 are usually safe, right? So what's 1 squared? 1. What else do you want to choose? 2. What's 2 squared? 4. That's still safe, right? What else do you want to choose? Think outside the box a little bit. Not the actual graph box. I want you to stay inside the graph box, but negative is what I wanted you to say. Yeah. What about negative 1? What's negative 1 times negative 1? Positive 1. Good. And you said negative 2 also? Okay. So negative 2 times negative 2? Positive 4. Good. What's one more that we usually like to choose? 0. Okay. If x is 0, what's y? What's 0 squared? 0. Okay. So let's plot these on the graph. 1, 1, 2, 4, negative 1, 1, negative 2, 4, and 0, 0. I know we don't have room for it on the table, but what would be another acceptable one if we wanted to fit it on the graph? 3, right? What's 3 squared? 9. I'm going to actually go ahead and graph that because we know that's true. What else would work then? Negative 3, right? Negative 3 is positive 9. Because see, that gives me a nice picture of it, right? Can I connect them? How do you know? We're given an equation. We got our table from our equation. So I also know it is continuous, right? And I know they can be connected. What's the x-intercept? Where is it crossing the x-axis? 0, 0. Where is it crossing the y-axis? 0, 0. Okay. What's the maximum point of this graph? Yeah, there's not one, is it? Because it keeps going. Okay. What's the minimum point on this graph? Oh, 0, 0. Nice. What does that also tell us something about? Yeah, the range, right? That tells us something about the range. If the lowest point is 0, 0, that means my y values have to be greater than or equal to 0 if I'm writing it in inequality notation, right? So what's that going to look like in interval notation? Isn't that very similar to absolute value? So from 0 to infinity. Tell me about my domain. Why? Because it goes all the way to the left and all the way to the right, correct? Good job. For the record, I know some people have a hard time drawing infinities, so some people actually turn their paper and then draw an 8 and then turn it back. That's okay. I won't laugh out loud at you when you do that. Intervals of increase. As I'm moving from left to right, where is it increasing? Oh, on the right-hand side of 0, isn't it? Okay. So if it's increasing on the right-hand side of 0, I'm saying from 0 to infinity. And where is it decreasing? On the left-hand side of 0, right? So if it's decreasing on the left-hand side of 0, I have negative infinity to 0. Oh! Ooh, I messed up. Did you see where I messed up? Can you fix it? Oh, it is. It's not a bracket. It's a parenthesis, isn't it? Sorry about that. Please forgive me. Because I just finished telling you, last problem, we don't include the point on the intervals of increase or decrease, right? And then I forgot that. Please forgive me. And behavior? Ready? As x is going to the left, what's happening to the y's? They're increasing, so what do I write? Positive infinity. As x is going to the right, what's happening to the y's? Also increasing. Good job. What's this called? you think? You know it's x cubed, and that actually tells you the name. It's a cubic because it's x cubed. Okay? Let's go to the table. What values of x should we choose? 1 is a really great one to choose because what's 1 times 1 times 1? 1. What else is really good to choose? 2 is good to choose because what's 2 times 2 times 2? 8. That's definitely going to fit on the table. Is 3 going to fit on the table? I mean on the graph? What's 3 times 3 times 3? 27. That's not going to fit, so let's not choose it. So what else should we choose? -1 is a good one to choose. What's -1 times -1 times -1? -1. What's another good one to choose? -2 is a good one to choose. -2 times -2 times -2? -8. And I need one more. 0. What's 0 times 0 times 0? Excellent. Graph them, please. So what I want you to be careful of when you graph this, well, first of all, can we connect the points? How do you know? Because we use an equation to get there. When you connect the points, make sure they're curves and not straight lines. Okay? So the bell's about to ring. So what I need you to do before you come back tomorrow is finish this one. Just this one. Don't go on. Finish this one. Got it? Peace.